Hi guys, so today we're going to talk about atomic structure. This is really kind of our first unit talking about just chemistry, okay? So today we're going to talk about atomic theory. Now, atomic theory says that atoms are the building blocks of elements. Similar atoms are going to be in each element. We'll talk about what an element is later, but there are specific types of atoms is another way to think of what an element is. They're different from atoms of other elements. So if the atoms look different, that means they are a different element, okay? So two or more different atoms will bond in simple ratios to form compounds. So when we have two elements that are going to bond together, we would call that a compound. Okay, so we're going to talk about all of those things today. So let's first talk about the subatomic particles. Each electron, so if you notice on the screen, has an E with a little minus on it. So that stands for electron. The electrons are on the outside, so those are going to be moving around very quickly. Their charge is a negative charge, and they're so small that the relative mass, we say, is 0. Okay, they're just really small and they move really fast, circulating around the nucleus. Okay, so electrons are outside the nucleus. The next particle I want to talk about is the proton. Now, protons, what does it mean to proton? What does it mean to be for something? Right? Like if you are pro something in politics or whatever, then that means you're for it, right? Or you're positive about it. So a proton has a positive charge and it's located inside the nucleus. We would say that the relative mass of a proton is 1. Also inside the nucleus is the neutron. And the neutron, we put a little n. We don't have a plus or minus sign by it because it has 0 charge. It's neutral. All right, so it's not positive or negative, it's just neutral. But it does have mass. Okay, so its relative mass we would say is 1. Again, so electrons, they have no mass, they're whizzing around, negative charge. Protons and neutrons are inside the nucleus, and they do have mass. So here's a picture. I think you should draw this on your paper so you'll remember what it looks like. You have the nucleus in the middle, and again, the nucleus is made of the protons and neutrons. And remember, protons have a positive charge, neutrons have 0. So what would be the overall charge of the nucleus? Positive, right. And then the electrons are going to buzz around outside. Those have a negative charge and they don't have any mass. Well, we say that their mass is negligible because it's so small we cannot even measure it. It doesn't make a difference. All right, atomic number. So the atomic number is the number of protons in an atom. Okay, so that by definition is what the atomic number is. It's the number of protons. The periodic table is where we're going to find all of the elements and they're going to be organized for us. They're going to be organized by atomic number, so by how many protons they have. In addition, they are organized according to how they act. Okay, so similar ones are going to go into groups, and those are the columns, and we'll talk about those more next week when we start into our periodic table trends. So that's the periodic table. So here, if you look, the periodic table is grouped, and this is just a short little intro. But we have groups 1 and groups 2, and then 3, 4, 5, 6, 7, and we end with 8. All right, and you notice there's a small block in the middle. We're going to talk about those later, but those are our transition elements. Okay, so this is what I want you to know this week. On the periodic table, if we have a symbol such as sodium, okay, Na is sodium, I want you to know that. And the next number that's above it is the atomic number. And the atomic number gives us our number of protons. Good. So here we would say sodium has 11 protons. And all atoms of the element will have the same number of protons. So any sodium element, in order for it to be called sodium, is going to have 11 protons. All right, so let's see if you can answer these problems. State the number of protons for atoms of each of the following. So just write these down in your notes and see if you can answer the questions. Nitrogen. So find this on your periodic table that you got in class. Nitrogen is N, okay, and it has a 5 as its atomic symbol. So it would have 5 protons, okay? And then look up sulfur. Sulfur has an S on the periodic table. What is its atomic number? How many protons does it have? And then barium. Barium is Ba. So try and find barium. Notice its atomic number. So what would be the answer to that? All right, here's our solution. Did you get them right? All right, so the number of electrons. When an atom or an element is neutral, the number of protons will be the same as the number of electrons, which would mean if we know the number of protons from the atomic number, then we can also know the number of electrons. And again, these are only for elements on the periodic table where we're saying that there's an overall neutral charge. We're going to get into ions and bonding and all of that, and so the charge will not be neutral. But for now, if you can think about the periodic table having neutral atoms, neutral elements, then the number of protons is the number of electrons as well. But on the test, definition of atomic number is the number of protons, not the numbers of electrons, okay? All right, the mass number. So the mass number, if you look on the periodic table, the bottom number, you're going to have a smaller number there, and that's going to be what makes up the mass. So remember, we said what two subatomic particles make up the mass? Protons and neutrons. So the mass number then is going to be the protons and the neutrons added together. Now, if we know the number of protons from the atomic number, can we get the number of neutrons? Yes, by simple subtraction. All right, so here we have the mass number is always going to be bigger. We have our mass number for sodium, 23, and our atomic number, 11. So then, how many neutrons does sodium have? So you would want to do the mass number, 23, minus the atomic number, 11. So what do you get? All right, more atom symbols. So here we can look at oxygen. Notice that the top number is the mass number, 16, and the lower number is the number of protons. And again, in neutral atoms, we can actually say that the number of electrons is also the number of protons. So now we know all the subatomic particles. We know the number of protons, the number of neutrons, and the number of electrons. All right, so what is an isotope? What does iso mean in geometry? What type of triangle is an isosceles triangle? Those are ones that have two of the same size. So iso actually means same. And in this case, an isotope, it means it's the same element or the same type of atom, and which means it has the same number of protons, but it has a different number of neutrons. So this is going to affect the mass number. All right, so let's look at the bottom here, isotopes of chlorine. Normally on the periodic table, chlorine has a mass number of 35 and an atomic number of 17. But an isotope of chlorine could have 37 as a mass number and 17 still as a proton, because remember, if we add a proton or we take away a proton, that means it's no longer chlorine, it's a different type of atom. Okay, so here we would say that the 37 is the isotope here. So in the first one, the naturally occurring one, we would have 18 neutrons, but in the isotope of chlorine, we would have 20. Okay. All right, so let's see. Naturally occurring carbon consists of 3 isotopes, carbon 12, 13, and 14. So we use this actually in radiometric dating, which is what we're going to talk about a little bit later in the semester. But just know that these are the most commonly found isotopes of carbon. So state the number of protons, neutrons, and electrons in each of these carbon atoms. So we have our regular carbon 12. We have an isotope of carbon 13 and another isotope carbon 14, which we do use in radiometric dating when we find a fossil or a piece of rock or something. Okay, so put the number of protons, neutrons, and electrons. Remember, the neutrons are going to be the ones that are going to change. Did you get it right? All right, what about this one? Now let's say we have an atom of zinc and we know that the mass number is 65. So now you have to go to the periodic table and look at the protons. All right, did you get it right? Okay, so we're going to do more practice with this, but I just wanted to give you a little experience with the subatomic particles, a little bit of introing what the periodic table is and how things are arranged, and then also just to introduce the idea of isotopes and how the mass number can change. Okay, so that's all you'll be responsible for tonight. Hopefully you took some good notes. If not, feel free to go back through the PowerPoint and watch this video again. All right, bye.